Hello dear students, I am Pranita Pant, TGT Science KVS. In today's video session, we shall take up part 1 of chapter 1, Chemical Reactions and Equations of class 10 Science. Topics to be covered in today's session are introduction of the chapter, observation to determine a chemical change, chemical equations, writing and balancing. The learning objectives of today's session are to help learners understand the meaning of chemical reaction, to help learners observe and list out the changes taking place during a chemical reaction, to enable learners to write a balanced chemical equation. Students, now let us consider the following situations of daily life and think what happens when milk is left at room temperature during summers. An iron tawa, pan or nail is left exposed to humid atmosphere. What happens when food is cooked or gets digested in our body? What happens when we respire? Now, let us discuss and find reasons behind these observations. You all must have observed the curdling of milk when left at room temperature during summer season. The milk gets spoiled and becomes unfit for consumption. Likewise, you must have seen a layer of rust being formed on an iron nail, pan or tawa when it is exposed to the humid atmosphere, especially during the rainy season. When the food gets cooked, its color and texture changes. Students, you have already learnt in junior classes that during the process of digestion, the large molecules of food are broken down into simple usable forms by our body. Similarly, when we respire, we inhale air rich in oxygen while exhale air rich in carbon dioxide. So, here we say that in all the above situations, the nature and the identity of the initial substance have somewhat changed. These changes are chemical changes. Now, let us move to our topic, chemical reaction. Whenever a chemical change occurs, we can say that chemical reaction has taken place. We can also say that when two or more substances react and form a new substance, it is called a chemical reaction. A chemical reaction consists of two types of substances, namely reactants and products. The substances that are mixed or react with each other are reactants, and the substances that are formed on account of a chemical reaction are called products. Now, let us try to understand these by taking few examples of chemical reactions. We all know that plants prepare their food by the process of photosynthesis. Can you name reactants and products in the process of photosynthesis? Yes, you all are correct. During photosynthesis, carbon dioxide and water are the reactants that combine using the solar energy and form new products that are glucose and oxygen. Now, try to identify reactants and products in rusting of iron. Absolutely correct. During rusting of iron, reactants are iron and moist oxygen, while the products formed are water and iron oxide, commonly known as rust. Now, let us discuss a few activities to understand more about chemical reactions. First activity is burning of magnesium ribbon. Now, let us together watch a video on burning of magnesium ribbon. Wasn't it interesting to watch magnesium ribbon burning? In the video, we learnt following points. Before proceeding to the activity, we always need to clean the magnesium ribbon using a sandpaper in order to remove a layer of carbonate from it. Magnesium ribbon burns with a white dazzling flame, leaving behind a white powder residue of magnesium oxide. The hard solid magnesium ribbon has changed into white powder. Is it magic? No, it is a chemical change or a chemical reaction. In this reaction, magnesium and oxygen are the reactants, while magnesium oxide is a product. Now moving towards our next activity, reaction between lead nitrate and potassium iodide. Materials required for this activity is solution of lead nitrate and potassium iodide and few test tubes. Take the solution of lead nitrate in a test tube, add a little amount of potassium iodide solution to it. Students, as you can see that both the solutions are colorless, but as they are mixed together, a bright yellow color is obtained. Again, is it a magic? Yes, it is a magic of science. Here, a chemical reaction is taking place between two colorless reactants to give yellow color product. Hope you all are able to understand what a chemical reaction is. Moving to our next activity, chemical reaction of zinc granules with dilute acid. For this activity, we need a conical flask, some zinc granules and dilute sulfuric acid or hydrochloric acid. First, take a few zinc granules in a conical flask or a test tube. Then, carefully add dilute hydrochloric acid or sulfuric acid. What do we observe? Some bubbles will start to form near the zinc granules and also the flask will become hot to touch. These gas bubbles formed are of hydrogen gas released during the chemical reaction. Now let us understand the purpose of these chemical activities. From the three activities that we discussed, we can say that any of the following observation help us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of a gas, change in temperature. Now, I hope you all will be able to identify a chemical reaction by these observations. If I tell you to write down a chemical reaction, how will you write? You will write the names of the reactants and products or a small paragraph. But it is not like how a chemical reaction is written or represented. Now, let us learn how to write a chemical equation. A chemical equation is the representation of chemical reaction in terms of symbols, molecular formula, moles, states, etc. A word equation shows changes of reactant to products through an arrow placed between them. The reactants are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS with a plus sign between them. The arrowhead points towards the products showing the direction of chemical reaction. For example, Mg plus O2 gives MgO. Mg represents magnesium metal, O2 is symbol for oxygen gas and MgO is chemical formula for magnesium oxide. The substances that undergo chemical change in the reaction magnesium and oxygen are the reactants. The new substance is magnesium oxide formed during a chemical reaction as a product. So, now you all know how to represent a chemical reaction. But is this chemical equation complete? In the above example, count and compare the number of atoms of each element on left hand side and the right hand side of the arrow. Is the number of atoms of each element same on both the sides? No, the number of oxygen atoms on both the sides are not equal. Left hand side has 2 oxygen atoms, whereas right hand side has only 1 oxygen atom. A chemical equation should always be balanced. But why? Let us try to find the answer to the question. A balanced chemical equation must obey the law of conservation of mass, which states mass can neither be created nor destroyed in a chemical reaction. This means that the total mass of the reactants and products participating in an equation must be the same. Or we can also say that total number of atoms of an element on left hand side should be equal to the total number of atoms on the right hand side. The process of making the number of different types of atoms equal on both the sides of an equation is called balancing of an equation. After finding the answer to the question, why do we balance a chemical equation? Now, next question is how to balance these equations. The simple equations are balanced by hit and trial method. The following steps are followed for balancing the chemical equation. Let us take an unbalanced equation to understand balancing. Fe plus H2O gives Fe3O4 plus H2. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing a equation. Step 2 is to list the number of atoms of different elements present in the unbalanced equation in a tabular form as shown here. Iron atoms on left hand side is 1 while on right hand side is 3. Hydrogen atom on both the sides are equal, that is 2. And oxygen atoms on left hand side is 1 whereas on right hand side they are 4. In step 3, we will start balancing with the compound that contains a maximum number of elements. In that compound, select the element which has maximum number of atoms. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compound or element involved in the reaction. Using the criteria, we select Fe3O4 and the element oxygen in it. Right hand side has 4 atoms of oxygen, whereas left hand side has only 1 atom in H2O. So, we multiply H2O by 4 or add 4 as a suffix to H2O. Now, the number of hydrogen atoms on left hand side becomes 8 after adding 4 as a suffix to H2O while balancing the oxygen atom. So, now in right hand side H2 will have suffix 4 to equalize the number of hydrogen atoms. In next step, now let us balance Fe atom. Fe atoms on right hand side are 3 whereas left hand side has only 1 Fe atom. So, simply by adding suffix 3 to Fe on left hand side, the atom of irons are equal or balanced. Now count atoms of each element on both the sides of the equation. The equation is now balanced. 3 Fe plus 4H2O gives Fe3O4 plus 4H2. This method of balancing chemical equation is called hit and trial method. So, we have seen that with the help of an example, how hit and trial method can be used to balance a simple chemical reaction. First, write the skeletal equation for the reaction using symbols and chemical formula and count the number of atoms of each element on both the sides of the equation. Select the biggest formula and balance elements of this compound by hit and trial, and then balance other elements one by one in the similar manner. After balancing the chemical equation, check the correctness of the chemical equation by counting the number of atoms of each element on both the sides of the equation. Do not change the formula of the substance while balancing the equation. To be precise, do not change the subscript of the formula, but only place a whole number before the formula to increase the number of atoms. Hope you have understood how to balance a chemical equation. You can practice some more questions. A balanced equation which gives more information about the chemical reaction is known as more informative reaction. Chemical equations can be made more informative by indicating the physical states of the reactants and products in an equation. Small letter S within the brackets for solid state. Small letter L within the brackets for liquid state. Similarly, small letter G within the bracket for gaseous state. For an aqueous solution, small letters AQ within brackets are written. An upward arrow shows that a gas is evolved in a chemical equation. A downward arrow represents formation of a precipitate or insoluble compound. Physical conditions like temperature, pressure, catalyst, etc. for a chemical reaction are indicated above and or below the arrow in the equation. For example, in a chemical reaction between carbon monoxide and hydrogen gas, the pressure condition of 340 atmospheres is written above the arrow. Similarly, in photosynthesis reaction, we write sunlight and chlorophyll above and below the arrow. So, students, at the end of this session, we can say that a balanced chemical equation is full of information about a particular chemical reaction. Now, let us have a quick recap of the points learned so far. A chemical change is always accompanied by a chemical reaction. When two or more substances react and form some new substance, it is called a chemical reaction. We can tell a chemical reaction has taken place if there is a change in state, change in color, change in temperature, or by evolution of a gas. We represent a chemical reaction using symbols of the reactants and products, and this representation is called chemical equation. A chemical equation needs to be balanced to obey the laws of chemical combination. It's time for an assignment now to practice and solidify the concepts further. Define a chemical reaction. Give characteristics of a chemical reaction. Balance the following chemical equations. First, HNO3 plus CaOH whole twice gives CaNO3 whole twice plus H2O. Second, NaOH plus H2SO4 gives Na2SO4 plus H2O. Third, NaCl plus AgNO3 gives AgCl plus NaNO3. Fourth, BaCl2 plus H2SO4 gives BaSO4 plus HCl. With this, we have now come to the end of today's session. I hope you have enjoyed it. Thank you very much. Happy learning.